All right, so this is a sample problem on PV diagrams. A gas is taken through the cycle shown in the PV diagram in the figure below. During one cycle, how much work is done by the gas? Now, just because this is a cyclic process doesn't mean that work is equal to zero. What is zero in a cyclic process is the change in internal energy. That is zero in a cyclic process. But work in this case is not necessarily zero. Not necessarily zero. So how can we solve for work here? We just have to solve for the area under the curve. So we could break this down into 4 parts. We could call this work 1, work 2, work 3, and work 4. So the work in this case would be equal to work 1 plus work 2 plus work 3 plus work 4. Now, obviously, work 1 and work 3 would be equal to 0 because this is an isovolumetric process. There is no area under work 1 and work 3, so we could cancel that out. Work 1 and work 3 is equal to 0. So we have work 2 plus work 4. Now, work 2, we could solve them separately, or we could just write it in this or substitute it in its equation. Now, nevertheless, let's solve them properly. So let's now solve for work 2. According to the formula, work 2 should be equal to negative P delta V. So in our work 2, what is our pressure for work 2? Anybody?
2 Pascal.
Say that again.
2 Pascal.
All right, it's not actually 2 Pascal, but instead it's 2 PO. So that's not PA right there. It's 2 P sub O. So in fact, we will have negative 2 P sub O. Now, our delta V, remember that our delta V is just going to be equal to final volume minus initial volume. So what is our delta V?
It's gonna be 4 minus 1.
Okay, that's gonna be, it's not 4 minus 1, but rather 4 VO minus VO. I would like to be very clear with that. So that's gonna be 4 VO. That's our final volume. So this one right here is our final volume. And our initial volume, which is in this case, would be VO minus VO. So as we simplify this, work 2 is equal to negative 2 PO multiplied by 3 VO minus VO is gonna, 4 VO minus VO is equal to 3 VO. So this gives us work 2 is equal to negative 6 PO VO. That's our work 2. Any questions? All right. Now we solve for our work 4. So let me write work 4 on this side. Similar process, that's going to be equal to negative P delta
Sir, can I ask a
V?
question?
Yes, tell me.
For W2, you wrote 4V minus 4V naught minus
Yes.
V naught.
Yes.
Well, from where did you get the 4?
From here. This look at the screen.
Yeah.
So this is our final volume. If you put it straight.
Oh, okay.
Straight down.
Okay, understand.
There. Any other questions?
No, thank you, sir. All clear.
Okay. So now let me just erase these parts. Okay. So now moving on to work 4. Still, that's going to be negative P delta V. Substitute our values. Now, what is our pressure for work 4? Anybody?
Negative PO.
Very good. So that's going to be PO. So we will have negative PO. And what is our delta V? So for our delta V for work 4, This one right here is our final, and this one right here is our V initial. So this is for work 4. So looking at that, could you please substitute delta V, anybody?
Delta V would be equal to VO minus 4VO.
Very good. So since our final volume now is VO and our initial volume is 4VO, so we will have VO minus 4VO, and this would give us negative P. VO minus 4VO is going to be equal to
Negative 3VO.
negative 3VO, and this is equal to work 4 is equal to positive 3 PO VO. Any questions? Any questions? All right, so now moving forward, solving now for our work is equal to W2, which is negative 6 POVO, plus W4, which is 3 POVO. Then our work is equal to negative 3 POVO. This is the answer, or no, is it the answer to the question now? So this work right here, is this work done by the gas or done on the gas? Is this work done by the gas or done on the gas? The work,
Done by
could you please go back to your notes? W is equal to negative P delta V. Is it work done on the gas or work done by the gas? These are actually two, although quite similar, but very, very different quantities.
This
by
is
the gas.
Is it? So this formula, W is equal to negative P delta V, is the work done on the gas. So this formula, please take note of this. This is the work done on the gas. So therefore, if we go back to the problem, the question is asking how much work is done by the gas. So what is the answer? Therefore, the work
So we have to add all of them, sir?
the work done by the gas is 3 POVO. This is the answer. Oops. This is the answer. So meaning to say, we just have to take the negative quantity of the work done on the gas, then that becomes the work done by the gas. Let me write that down. So work.
So, sir, if one of the answers were positive, do we add it?
No,
to
if one of the answers were positive, then that means you will have to choose that answer, because again, this formula right here, the ones that we have been using, let me highlight down this formula for work 4, and then this formula for work 2, they are all work done on the gas. But then the question clearly is asking us how much work is done by the gas. So meaning to say, if you have the work done, let me write this down, very important, work done on the gas is just equal to the negative of the work done by the gas. So that's the reason why in this case, if we were able to solve for work, which is work done, this part right here is work done on the gas. So to answer the question work done by the gas, that's going to be the negative of the work done on the gas. Questions? All right. Now, if the question is asking how much work is done on the gas, what would be the answer? Just to,
Negative 3 POVO.
very good. But why did we take, why is the answer positive 3 POVO? Because
it's the work done by the gas.
Exactly, because the question is asking for the work done by the gas. Any questions?
No, Mr. All clear.
All right, I need you to take a screenshot of this part. Take a screenshot of this, and I need you to apply this formula and concept to solve slide 26. All right, I expect everyone to make a submission to slide 25, and then I'll mark you present. You have about 15 minutes to solve the question on slide 26. And be very careful again whether it's asking for the work done on the gas or the work done by the gas.